All right, Logic fans, what's up? Welcome to our third video on section 5.8. So this is 5.8c. And I do want to look at some arguments for you to demonstrate invalidity and to put your skills to work in expanding sentences with identity. But before we get there, I do want to make a point of comparison about these two propositions and how they're expanded. So what I want you to do now is expand this sentence on 1, 2, and 3 objects. This is the solution from last time to this particular sentence. Now, these two sentences may look the same, but they're very different, and we went over a very similar concept with relations. Okay, the main connective of sentence 1 is the for all, so its main connective is and. Okay, the main connective of 2 is not for all, right? It's not a universally quantified sentence. 2 is a conditional. Its antecedent is a universally quantified sentence, and its consequent is a universally quantified sentence. Okay, so I've designed these to look similar, but they're not. And my question to you is, can you expand sentence 2 with 1, 2, and 3 individual constants, and therefore get yourself to appreciate the difference in what these two sentences mean? Pause now. Okay, so we have to start with trying to understand the sentence. This says, on the condition that everything has this property, then everything is identical with everything. Okay? Everything is identical with everything. So this says, right, provided everything has this property, this whole thing holds. This sentence, by contrast, said everything is such that it satisfies this description, right? So they're very different sentences, and you can get yourself to sort of appreciate that. Now, you're not going to get yourself to appreciate it on the one object case, because the expansion of 2 and the expansion of 1 for the one object case is identical. It's the same one. It's this solution. However, let's look at the two-place solution to this sentence, okay? Versus the two-place solution to this sentence, two-object solution, two individual constant solution. So here's the solution to this particular one. Let's look at this one. I'll do it right underneath of it. Hopefully we've got enough space here so you can see it. But this says if everything is F. So if A is F and B is F, then something holds. Okay? So what holds? In that case, then and only then is it the case that everything is identical with everything. So you're going to have A is identical with A. You're going to have A is identical with B, right? You're going to have B is identical with A. And you're going to have B is identical with B. Okay, so I'm going to actually move the whole consequent down, okay? But yeah, the whole thing looks like this. So notice, this is very different, right? The main connective of this is the if-then, because the main connective of this sentence is the if-then. The main connective of this is the and, right? Because it's a universally quantified sentence. And so this says, on the condition that these two things hold, then all of this holds, right? This says A satisfies this description and B satisfies this whole description. Okay, so they're very different. So you can picture like modus ponens and modus tollens, and to really get yourself to see that they're not the same thing, you could try to make this sentence true on an interpretation and this sentence false on an interpretation. Okay, and we're going to do that right after we do the 3-object expansion of this particular sentence. So the 3-object expansion, okay, is not going to look like this, right? What it's going to look like is basically this one, except it's going to have it's going to look just like the 2-object one, except it's going to be extended for the 3, right? So it's going to start off with, it's going to have, okay, if FA and FB and FC, if everything is on the condition that everything is F, okay, if that holds, then this other thing holds, which is that everything is identical with everything. So it's going to be all of these things together. So, we'll just think about it that way. And so I'll write it out this way. Okay, so here's the antecedent. here's the main connective, and then this whole thing here, this whole thing is the consequent, right? And it's got, then A is identical with A, is identical with B, A is identical with C, and so on for B and for C, okay? Then all of this holds, okay? All right, so let's go ahead and see if we can't get ourselves to intuitively appreciate that these sentences are not the same thing. And we can do that by reimagining this as an argument. To do that, what I'm going to do is I'm actually going to reverse the premise and the conclusion. So this one is going to function as our premise, and this one is going to function as our conclusion. Interesting question for you. Ask yourself, why am I doing that? Okay. But anyways, so this is going to be our premise, this is going to be our conclusion. If we can provide an interpretation, let's say in two objects, according to which the conclusion is false and the one and only premise is true, you will have demonstrated the argument to be invalid, which intuitively shows you that these sentences do not mean the same thing. It'll get you to appreciate the difference between them, okay? So, let me put up for you, since we've already done it, the two-object expansion of these. So here was our two-object expansion of what is now our premise, and here was our two-object expansion of what is now our conclusion. Your object is to provide a two-object interpretation according to which the conclusion is false and the premise is true. See if you can do that. Pause now. Okay, so the first thing you have to do is you have to set up your table, right? And our table is just going to look like this. You're going to have your domain. We're doing it with two objects, so A and B. Then you've got your one and only property constant. And then I've left out a lot of these. You can include them. It wouldn't harm anything. But, you know, A is identical with A is trivial, as is B is identical with B, right? Those have to be true, otherwise failed correspondence, right? Similarly, I don't need both A is identical with B and B is identical with A because, you know, if this one's true, this one's true. And if this one's false, this one's false. They have to have the same truth value because identity is a symmetric relation, right? So, can you fill this in such a way that the conclusion is false and the premise is true, right? I'm going to go through it now with you, but the basic idea is fairly straightforward here, right? We need the premise to be false. We need the conclusion, right, to be false. The conclusion is an ampersand, so we need at least one of the conjuncts to be false. Let's take this one as an example. So we need FB to be true, and then we need the entire consequent, right, to be false. And the way we're going to do that, of course, is by making this take the value false. So now we've accomplished by making this conjunct right here false. The entire conclusion is in fact false in virtue of that. And so consistent with that, we have to make the one and only premise true. If you haven't had a chance, pause now and see if you can complete it from here. But there's only one thing really that you can do, okay? And that is we have to make this true. And since we've already got, you know, FB being true, and we've already got the consequent is going to be false, right? Because A is identical with B is false. So this entire consequent is false. In order to have a true conditional, you have to have a false antecedent. And so that's exactly what we're going to do here. And that succeeds in making the one and only premise true. So here's an interpretation in two objects according to, and no failed correspondence issues, right? These not identical, so they can have different properties, which shows that you can have one of these sentences true and the other one false at the same time, okay? And so those sentences do not mean the same thing. Let's look at some more examples where you can really put your skills at expanding identity sentences to work, and they can really come to your aid in demonstrating invalidity. Okay, let's try another one, all right? And in this particular case, let's do it in two objects, okay? So you got two premises here and a conclusion. So it says everything is F, everything is G, therefore there exists at least two things. There's an X that's not identical with a Y, right? Okay, pause now, and you might want to expand things, and then it'll tell you how to do your interpretation. All right, so in two objects, if everything is F, right, that one's pretty straightforward. That's just going to be FA and FB, right? And if everything is G, similarly, you're going to have GA and GB. So we're going to need both of those true. And then you're going to, if you were to expand this completely, what would you get? Well, you'd get that, A is not either, right? A is not identical with A, or A is not identical with B, right? And so on, right? And you would have 4 of them total, right? So it would end up looking just like this. And of course, A is not identical with A is false. A is identical with A. It doesn't matter what A is. That's going to be true. So you'd get the B cases, right? So we can narrow this down a little bit to help ourselves out. Since A is going to be identical with A and it's an OR, we don't need to worry about that, right? So we really need to be thinking about the case where A is identical with B or A is not identical with B or B is not identical with A. We don't need B is not identical with B. That's going to be true. So really what we want to think about here, in particular since we're trying to make the conclusion false, right, is one of these cases. And we can really reduce that down to this, because if A is not identical with B, then B is not identical with A. So this would be roughly our expansion that we can use to help us find an interpretation according to which this argument is invalid in two objects. So see if you can finish it from there. Okay, so first thing you want to do, right, is of course get set up on your table, right? And your table is going to look very similar to the last one we did, but you've got your two objects in your domain. You've got F, and then of course, what am I missing? We're going to have an extra column, right? Because now what we've got is the G of X situation right here, right? So we're going to need to handle the G, and then as we noted, we only need to worry about this case. So easiest thing to do here probably is just to make the conclusion false, right? So we want to make it false that they're not identical. In other words, we need them to be identical. So we're going to put a plus there, and that will make the conclusion false, right? Now what we need consistent with that is for the premises to be true. Well, that will happen in a situation and only in this situation, just like this. Okay, so here's an interpretation in two objects according to which the premises are both true and the conclusion is in fact false, right? So, being able to do these expansions really helps, okay? I'm going to do one more video on this where we'll look at another example or two of using identity expansions to demonstrate invalidity, okay? So we'll catch you on 5.8D.